Binds. Hope you are listening well this remote sensing and GIS. Now we are here. We have successfully completed the first unit where we have discussed the basic things and basic introduction parts in the name of remote sensing and geographical information system, which holds the elements like electromagnetic radiation, electromagnetic spectrum, and we have seen how the electromagnetic spectrum is interacting the atmosphere, as well as how the interactions are on Earth's surface. Followed by, we have seen different topics that are mentioned in your syllabus book: IRS, Indian Remote Sensing, and Cartosat, RISAT. Of course, we have seen Landsat and all. See here, with that, we are finished the first unit. I mean, whatever we discussed earlier are completely understood by you. And now, with that hope, we are entering into the part that is second part. In the second part, in the sense, second unit, in the first unit, we have seen, in the first unit, we have seen the images or else the target properties which holds the characteristics are recorded by the sensors. Now, whatever the sensors are recorded, that has to be sent to the processing station. When we have a look at the basic components of remote sensing, we have seen 5 basic components. In that, the processing stations or else processing, transmittance, or analysis of data, also one of the component we have discussed. We have seen and we discuss the electromagnetic radiation that is reflecting from the target holds the image of the target. If it is interacted in the atmosphere, how it is going to be and what are the interactions that can take place, we have seen. Now, whatever sensor recorded, that sent to the processing stations. In the processing station, what happens? How we can get that image and how we can analysis. How can we can analyze those sensor sent images, sensor sent informations, or so information, sensor sent information to the processing station. We are going to discuss here. In the first topic of second unit, the first topic is elements of visual interpretations. See here, elements of visual interpretations. See here, elements. This is the one word here. Visual is the second word, and third, interpretation. That's what you are able to look here, 3 words: elements, visual, interpretation. The question is, write a detailed notes on elements of visual interpretation. You may get it. See, what are those elements? By seeing, visual in the sense by visualizing. You are visualizing this slide. Likewise, when you are visualizing the data, what you received or what you hold in the processing stations, you may have the basic knowledge, or else the persons who holds the domain knowledge may interpret by seeing the data before interpretation itself. Did you understand what I'm speaking? See here, for suppose you are not feeling well and you may approach doctor or you may approach anyone. Today I'm not feeling well, and you may quote what you are suffering, like body pains, some eyes are burning, something like that. When you are speaking and when you are sharing what you are struggling, the other person sometimes may can easily can detect because of what you are suffering. Nowadays, we all are hearing the incomfortness in breathing, discomfort in the throat, and maybe cold and body pains. You need to diagnose immediately. That's what you are keep on alerting. That's what you are getting information almost from most of the domains. When you made a call to someone, you may hear the same thing. When you switched on a television in your home, you may visualize same pop-up window, cautioning. That means you are suspecting so and so. If anyone is having all these things, he or she may suspecting something. Likewise here, visual image interpretation. How you can understand before interpretation itself. By seeing the visual, you can give the information of what it is. For suppose, you are in the classroom, you all are in a classroom, and you all are hearing one voice which is very familiar to you, and immediately your mind can give the information so and so person is reaching to you. How it happens? Even you are not looks him or you're not spotted him, but because of his voice, you are able to interpret who is coming. In the same way, by seeing certain key elements, the interpreter can easily understand this is, or else this might be so and so. What are those elements? That's what we are going to discuss. What are those elements? By knowing, or else by visualizing those parameters in the images, or else in the data, the interpreter can easily understand what it is. What are those elements? The first one is the first parameter is size. See, when the interpreter is analyzing the data, who has the domain knowledge and who has the handful of experience. Before processing of the data itself, by seeing the objects that are existed in the film or else in the information or else in the data, you can easily interpret how the size is one of the parameter when you are interpreting spatial images. For suppose the interpreter or as the analyst is visualizing a spatial distribution or a spatial map or a spatial information of one particular urban area, by seeing the data, he can easily understand, oh, it might be in a residential area, or else this is maybe a commercial area. How he can interpret it, how he can understood, and how he is analyzing. See, the size of the commercial buildings are always larger than the size of the residential buildings. If any area, the size of the buildings is much more and is high than the normal buildings, you can interpret that area might be a commercial area because of the sizes of the buildings, because of the sizes of those shopping malls, or as because of sizes of those large scale construction taking place over area, or as large scale constructions, we can conclude that this is the residential area and it is a commercial area. That's why the size also one of the parameter to interpret the spatial data. Now the second one is shape. Sometimes shape also gives the information to the analyst how he can interpret based on the size. In the previous case, we can easily understood what is the residential area and what is the commercial area. In here, if he has an image, if he had an information, spatial information of one particular location, for suppose if it is in a forest information, the large coniferous trees looks like circular in shape in a vertical angle. In a vertical angle, when the analyst is performing to find out the features of a forest, if the trees hold circular dome-like appearance, he can conclude this is an area where large number of coniferous trees are existed. Whereas the coniferous trees looks like a circular dome in a vertical angle, whereas the other trees does not hold such type of shape, such type of shapes, so that he can easily understand which type of trees are large in number, or the forest belongs to which type of whether the forest has these types of trees or not, he can easily understand. The third one is shadow. And sometimes shadow also speak what the image is. There are certain images, there are certain objects on the earth which always reflects with their own shadows. Example, large single isolated poles or towers, or as large suspension bridges always holds their shadows. If it is in a horizontal, we can conclude it is in a suspension bridge because it has in a shadow. Based on the shadow of the image, based on the shadow that is exhibiting in the spatial data, it can be easily interpreted by the analyst. It might be a suspension bridge. By seeing single isolated tower with its own shadow, he can easily understand it might be a tower. The next one is tone. Here, what is tone here? Tone in the sense, tone or color. See here, there one word is there. The electromagnetic spectrum recorded by remote sensing may be displayed in shade of gray ranging from black to white. See here, the spatial data that is recorded in the electromagnetic spectrum at all the bands appears with a resolution of white to black. That is called as grayscale. Sometimes if you holds a native of an image, it gives white appearance if light is heavy, and if an object is there, it gives dark appearance. In the same way, the remote sensing data which is recorded by electromagnetic spectrum in the name of different spectral bands, it appears as a grayscale which has or which resembles from white to black is called as tone. If the object, how the tone also one of the parameter, and what is the example? For suppose, if the sensor recorded the image of sand or as image of one desert where large quantity of sand or as sandy soils, if the sand is wet, it gives dark color. If sand is dry, it gives light color. That means in the spatial data, if it holds black in nature, or it resembles with black, when he is visualizing the data of sandy soils or as sand related issues, sand related objects, if it gives black resolution, he can conclude that the sand is wet. If sand is dry, it gives white or as light appearance. Okay, this is what about tone. Coming to the texture. What is texture? Texture in the sense nothing but here the appearance of an image. The appearance of an image in one particular area, for suppose, large number of trees are planted. It gives one appearance when compared with the other area where the trees are planted here and there. See here, texture reference refers to the frequency of tonal variation in an image. It depends size, shape, pattern, and shadow of terrain features. Same reflected objects may have difference in texture, help in their identification. How and what? When you have a look over there, one is grassland, the other one is other. This is the grassland, the other one is normal area. See here, this image gives smooth texture because the plants are planted in an uniform way, so it gives a smooth texture when compared with this nearby trees grown up here and there naturally. That means based on the texture of the images, we can conclude whether it is in a grassland or whether it is in a area of trees based on the texture. What the texture is influencing the size, shape, pattern and shadow of the objects influencing this texture. If the texture is smooth, we can conclude it might be a grassland area. In this example, when interpreting an area, if the texture is an open area, if the texture is smooth, we may conclude there might be a grassland area, whereas the other area where the plants are existed naturally here and there, it gives rough texture. Now next one is association. The other parameter is association. Sometimes this is also one of the parameter to interpret the objects of the image. For suppose as a teacher or else yourself only, you have a knowledge, you and your friend always associate to each other in the classes. If X is not coming to college, obviously Y may not come to college. That means the X is always associated with Y. If the X is in campus, most of the times the other people can expect Y also may be in the campus, because these two are thick friends, and from the beginning they both only come to the college. They never come singularly. They never come as single into the college. This is not exact. This may not happen exactly, but most of the cases, if we are as a teacher observing, if two of the friends used to do the same thing, what I am focusing is here association. Always good association is always good. That is of course that you know. But what I am stressing is here, if if in a building area is associated with an empty area in a colony, or as in one particular area, we can conclude it might be a high school. This might be a college, because the college always holds playground, or as the high school always associated with playground. Even buildings, large scale buildings with an empty area in front of those buildings, which resembles parking area of those commercial malls, shopping malls. That means if these two objects are existed by side, the analyst can understand there might be a school, or is there, based on the building capacity, building structure, this might be a school, or else this might be a parking area. I mean, this might be a commercial area, shopping area. Association is one of the parameters. The buildings are associated with empty area. It gives an information. Either in a colony, it might be a school, and in a commercial area, based on the shape of the buildings and the empty area, analysts may conclude this might be a commercial complex. This might be a shopping mall. And next one is site. So here, sometimes the geographical conditions of an area also gives what type of site it is. If anyone observing the hilly areas, the reflectance pattern is always differ with the hills where heavy snowfall is observing when compared with the other areas where there is no chance of snow. That's what we are discussing. The reflectance ratio is high at Himalayas when compared with the other areas, like whether other hilly areas like Ooty and Kerala. Of course, not Ooty in Kerala. Of course, during certain seasons, the snowfall may be observed, but as part of Indian conditions, the reflectance at Himalayas is always differ with the other hilly areas. When we have a look over here, elements of visual interpretation, the size is one of the parameters which gives the information to analyst what it might be and what the image holds. Then shape, the circular dome shape of coniferous in a vertical angle, it gives the information of the trees. Shadow, the long, large or as large single isolated towers and suspension bridges of at a large areas, covering at large area, always reflects with their shadows. Then tone, example, certain objects like sand. If it is wet, it will be appear as black, and it is dry, it may appear as white, the grayscale of electromagnetic spectrum. And then association, sight, pattern, all these are about the key elements of visual interpretation. We are in the unit 2 where we are discussing about the image analysis. The first one is elements of visual interpretation. Here these three words, elements, that's why I didn't mention here of elements, visual interpretation. If it is in a classroom, we can understand we used to split for more understanding, but it is not possible for all the topics and all the sentences. Here, size, shape, shadow, tone, texture, pattern, association, sight, all these are about the key elements of visual image interpretation. Now, hope you understood the topic, how an analyst can understand what the spatial data holds by visualizing those key elements in the spatial data before it is going for isolating or else identifying exact characteristic features of an image. Now, the second topic is digital image processing. Here, digital image processing. See here, digital image processing. What is the need of this digital image processing? See here, and we discuss interaction of EMR with atmosphere. There we discussed the Rayleigh scattering, Raman scattering, non-selective scattering, and absorption. All these may take place. That is somehow that has to be happen. That has to be happen as the EMR is traveling from the target to from the space to target, target to space. That means to the sensors. There might be a loss of some energy, some energy. If the EMR is lost in a considerable way, there will be a loss of image features also, or else there might be occurrence of certain flaws during the process of remote sensing operation technique, operation of remote sensing technique, which should be rectified. It should be rectified. If the flaws are not rectified, we may not get the image of the target, and you may not get the exact characteristics of the target. See here, that means some sort of correction is required after the information reached the processing station. What is the correction that is required? We are going to discuss, and what are those techniques we can apply in correcting the image, or we are going to discuss in the name of digital image processing. See here, the pattern or as the correction of images we can name before we are processing this image. There must be a pre-processing. What is the difference and what is pre-processing here? For suppose you are full of hungry, and it is happened to meet on fruit vendor who is selling apples at middle of the commercial area. You bought an apple, and you may not eat directly there itself. Even though your hunger is demanding, sometimes you used to clean the dust which is stick to the fruit, which is fall down on the fruit from all the commercial activities, as the vendor is selling fruits in a commercial area where huge amount of dust particles are expected to fall on the objects. That means the cleaning of the fruit is here pre-processing. Then only you can get why you are cleaning there itself. You are not cleaning with any water. You are not cleaning with any other specific parameter. You are not cleaning the fruit by following with any specific parameter. Here, all of a sudden you are cleaning the way you can, as much as you can, before that is subjected to processing. That means here the correction is named as image pre-processing, and it is divided into two categories. Before processing, the pre-processing, the techniques that are applying to make this image to be fit for processing is image pre-processing. Making of the image to be fit for processing by applying the techniques like what we are going to discuss, we call it as image pre-processing. The whole mechanism of this image processing, the whole concept of image pre-processing has been divided into two categories. One is radiometric corrections and another one is geometric corrections. What is radiometric correction here, and how we are going to correct the image? We are going to process the image here. Before that, what type of flaws here we are going to correct? See here, radiometric errors may occur at data recording instrumentation because of the incorrect calibration of detectors or incorrect function. How these flaws may occur? What is the prime cause of these flaws? That means because of the incalibration of sensors, because of non-functioning of the detectors, these types of errors may occur. What type of errors? Replacing missing scan line. What type of error? The first one is replacing missing scan line. That means what type of error? There might be a possibility of missing a line. Here, when you have a look over here, these zeros are as these 85, all these numbers are digital numbers. These are directly reflecting the characteristic features of image what we discussed in the earlier sessions. What is the first radiometric correction? Replacing missing scan line. Replacing missing scan line with what? With digital numbers. How you can replace this missed scan line with digital numbers? That's what we are going to discuss in this technique. See here, missing scan lines occur when a detector fails to operate during a scan. See, and because of the failure, those in that particular line, the digital numbers will be zeros where you may not visualize, which resembles black in appearance. That means those lines has to be filled up, then only you can get the image. In most of the instances, the objects on the earth which are recorded by sensor at the points which are close to each other may hold the similar characteristics. Once again, most of the cases, the objects on the earth at a close point of view, they hold similar characteristics. See here, that is the reason. That means this, what I'm speaking is, most of the objects at a closed point may hold similar features. That is the reason we can remove this missed scan line by replacing with the digital numbers which we got by averaging of the previous line and the subsequent line. That means 170 plus 221 by 2, whatever the value you got, that is going to depict here, and 238 by 2, whatever the value you are going to keep here. 85 plus 238 by 2, the value is going to depict here. 255 by 136, the result by 2. The same way, the line digital numbers will be depicted here. What is the title here? Replacing missing scan line. How it comes? Because of the incalibration of, or it's because of malcalibration of detectors. Here my question is, if two lines are missed, what you are going to do? That means when two lines are missed, the previous line values are, the first line values are replaced as it is with the previous values. That means here 170, 238, 85, 255, 221, 0. Likewise, the first line values will be filled up. Once we got the first line values, again the values of this line and this line, again summing and by 2 will be filled up here. Understand? Once again, if two lines are missed, the previous line values are repeated with the first line values are repeated with the previous line. That means this is the first line, this is the first line, and it is the second line. The first line values are repeated with the similar values of the previous line. Once we